Good morning, good afternoon, and good night. Today I'm going to review the fluency questions from the Completing the Square and Shifting Parabolas worksheet from emathinstruction. Number 1. Which of the following equations would result from shifting y equals x squared 5 units to the right and 4 units up? So it really depends on if it's a vertical transformation, meaning up and down, or a horizontal transformation, meaning left to right. So we're shifting 5 units to the right. So that's horizontal. And that means that we're going to be inside the parentheses. It also means it's going to be the opposite of what we see. There we go. So 5 units to the right, that's horizontal. It's a horizontal transformation. So that means you're inside the parentheses. You're directly affecting the x values. The x-axis is horizontal, but it's also the opposite. So if you want to move to the right, which is the positive direction, you're actually going to subtract 5. Then we have another translation, which is 4 units up. So this one is actually a vertical transformation. It's outside the parentheses. And it's not the opposite. If you want to go up, you add. If you want to go down, you subtract. It's outside the parentheses because we are affecting the y values. The y values are the solutions. So we are affecting the entire answer. So if you want to shift the y values or the entire answer up 5 units, you would add 5 outside the parentheses. So if we look at our options, which one is subtracting 5 inside the parentheses? Oh, not 5, 4. Sorry. And adding 4 outside the parentheses. That's choice 1. And that's how you can show your work, show your thinking. So this will be your parent function. That would be if we did not do any transformations to the parabola y equals x squared. The vertex would be at 0, 0. But now, because of these translations, we're going to shift to the right 5 units and up 4 units. This vertex will also shift. The whole parabola will shift. right? It will shift to the right 5 units, 1, 2, 3, 4, 5, and up 4 units, 1, 2, 3, 4. So our vertex is now 5, 4. And the parabola would be here. Instead. That's why this is called vertex form, because you could look at the equation and see what the parabola is. I'm sorry, you could see what the vertex is. It's the opposite of inside. That's your x, and that's your y. That's the vertex. Let's try number 2. Which of the following represents the turning point of this parabola? Oh, we just talked about that. So vertex form is y equals x minus h squared plus k, where hk is the vertex. So here, my h is -3. And the k is -7. And it makes sense. This says +3, so it means that the parabola was shifted to the left 3 units. And this is -7 outside the parentheses. That means the parabola was shifted down 7 units. Let's just jot that down. Left 3 units. Up, sorry, not up, down 7 units. So our answer is choice 4. Which of the following quadratic functions would have a turning point at 6, -2? Couple ways you could look at this. The 6 means it's been shifted. The parabola has been shifted 6 units right. And this -2 means it has been shifted or translated 2 units where? Down. So now we go to the choices to see which one will have a -6 inside the parentheses and a -2 outside the parentheses. Choice 3. Which of the following is the turning point of y equals x squared plus 12x minus 4? What we could do is use the turning point, the vertex formula. This is to find the turning point, -b over 2a. We can also call this the axis of symmetry. This is the line that will cut the parabola in half. And that line, that axis, goes through the turning point. So it will just give us the x value. Then we'll use that x value to find the y that goes with it. So my a is 1. My b is 12. All I need is a and b, right? We're taking this from standard form, ax squared plus bx plus c. So a is the coefficient of x squared, it's invisible. And b is the coefficient of x. So it says 12x, so b is 12. So we plug it in. X equals negative 12 divided by 2 times 1. That gives me negative 12 divided by 2, which is negative 6. So that's my x value. Because it's multiple choice, I don't have to go any further. I know that negative 6 is my x value, and that's the only one who has the x equals negative 6. And if I substitute negative 6 back into this equation, and I do negative 6 squared plus 12 times negative 6 minus 4, I will get negative 40. So that would be my turning point on my vertex. Let me just give you a little visuals, just so you understand what I just said. If we have our parabola, the axis of symmetry cuts the parabola in half. And this axis of symmetry, this line, is at x equals negative 6. X equals negative 6 is a vertical line that goes through the x-axis at negative 6. And then this coordinate has a x value of negative 6. But what's the y? Well, if you just substitute negative 6 back into the equation, you will get negative 40. So that gives you the turning point. Number 5, in vertex form, the parabola y equals x squared minus 10x plus 8 would be written as, okay, so to write this equation in vertex form, we can complete the square. Vertex form always has a binomial being squared, okay? And that represents the horizontal shift of the parabola. So let's complete the square and rewrite this equation in vertex form. The first thing we do is focus on the first two terms, and we'll slide this plus 8 down because we really want our new c so that we can write this as a perfect square trinomial. So we need to know, what is our constant that will make this a trinomial, a perfect square trinomial? Well, we take the b term, c equals the b term divided by 2 squared. So we'll do negative 10 divided by 2 squared, which is just negative 5 squared. So we get positive 25. So in this box, we're going to add 25. But if we add 25 to the equation, we also have to subtract 25 to keep things balanced, right? If you don't subtract the 25, then you're changing the whole equation. So now we have a perfect square trinomial. X squared minus 10x plus 25 is a perfect square trinomial. So let's rewrite it as a binomial squared. What is the binomial that we squared? Well, if our last term is 25, it must have been a 5 as a second term. And the first term is x squared, so it must have been x. What symbol goes in the middle? Well, our middle term is negative 10, so we must have had a negative 5. So x minus 5 squared equals x squared minus 10x plus 25. And then what is negative 8 minus 25? It's negative 33. So there we have it. We have just rewritten a quadratic equation that's in standard form in vertex form. The vertex would be, if they asked, they didn't, but just letting you know, the vertex would be positive 5 and negative 33. Because of this minus 5, we know it's going to be a positive 5 for x. It's been shifted to the right 5 units. And the y value, or the constant, tells us our y, negative 33. It's been shifted down 33 units. So that answer choice is 1. The turning point, number 6, the turning point of the parabola y equals x squared plus 5x minus 2 is, so this one, we're going to complete the square again. Let's write in blue. So y equals x squared plus 5x minus 2. First, we separate the x squared plus 5x. And we're going to find the new c value that makes this trinomial a perfect square. And we bring down the minus 2. Don't forget the minus 2. So we find the c by dividing b by 2 and squaring it. So b is 5. 5 divided by 2 squared. So what's 5 divided by 2? 5 divided by 2 is 2.5. And 2.5 squared is 6.25. So that's our new c term. Okay, something's wrong. I don't see it. Okay, I'm right. Plus 6.25. And then 6.25, since we added it inside the parentheses, we have to subtract it outside the parentheses. Let me get my highlighter. Okay, so I'm going to come over here. This is where we started. This is where we're ending. Good to keep your work organized so whoever's reading is not all over the place. So how can we write this as a perfect square, binomial, as a binomial squared? Well, I know my first term has to be x, because my first term is x squared. And this, I'll take the square root. Just like up here, to get 5, we just took the square root of 25. I'm going to take the square root of 6.25. But just think, how did we get this 6.25? We squared 2.5. So I know this has to be 2.5. So what is our symbol in the middle? Well, our symbol is positive 5, positive, a plus sign. So this has to be plus. And now, what is 2, negative 2 minus 6.25? Well, that's minus 8.25. Now that my equation is written in vertex form, because I just completed the square, I know that my vertex is negative 2.5 and negative 8.25. Choice 3. See all this work? This is why you can't just circle an answer and then expect to get full credit. No, ma'am. Okay, number 7. Write each of the following quadratic functions in its vertex form by completing the square. Then identify its turning point. Okay, let's go. Make this a little bigger. So first, we separate. And determine the new C. C equals B divided by 2 squared. The B is 12. Oh, that sounds familiar. 12 divided by 2 is 6. 6 squared is 36. So we will put a plus 36 as our new C. Because we're adding 36 to the equation, we have to subtract 36. Next, we rewrite the trinomial x squared plus 12x plus 36 as a perfect square. X, because of the x squared, plus, because our middle term is positive, and 6, because the square root of 36 is 6. Now, what is 50 minus 36? 14. So our vertex is negative 6, 14. I hope you pause the video and try B just to see if you understand it on your own. And then you could play to see if you got it right. Let's do it. Ooh, this one has a coefficient of negative 3. So we're going to factor that out. Because completing the square only works when the coefficient is 1 for x squared. So if we factor out a negative 3 from these first two terms, it's going to be negative 3 times x squared plus negative 3 times, well, I'm definitely not going to put 30x. I have to think, negative 3 times what will give me 30x? 10x. Okay, so now we find our new C. C equals B over 2 squared. My B is 10. 10 over 2 squared. Oops, squared. So that's 10 divided by 2 is 5. 5 squared is 25. So 25 goes in here plus 25, which means I then have to subtract 25. Keep the equation balanced. Oh, I'm forgetting something. It's not minus 25. Don't forget this 3. So we actually have to multiply this minus 25 by 3, right? So it's going to be minus 3 times negative 25. Okay? Okay. So let's simplify all this. Negative 3 times, there's a binomial squared, and that binomial is x plus 5, because x plus 5 squared is x squared plus 10x plus 25, right? And now let's simplify this piece. 7, negative times negative is a positive. 3 times 25 is 75. So now 75 plus 7 is 82. And now I can see what my vertex is. The parabola has been shifted 5 units to the left, right? Even though it said plus 5, you would think it's to the right, but it's not. It's always the opposite when it's inside the parentheses. So it's negative 5, and it's been shifted up 82 units, so my y is 82. Use the formula x equals negative b over 2a to find the turning points of each of the following quadratic functions. Then place the function in vertex form to verify the turning points. All right, let's do it. So first, let's use the formula x equals negative b over 2a. So what is my a? A is the coefficient of x squared, 5. And what is b? B is the coefficient of x. Comes from standard form, y equals ax squared plus bx plus c. So b is negative 30. So we're going to carefully plug these in. Not c, x. X equals negative b over 2a. So if b is negative 30, then negative b, which means change the sign, is positive 30. Divided by 2 times a. A is 5. So we have 30 divided by 10, which is 3. So I know the x of my vertex is 3. Now I'm going to find the y, because it says use this formula to find the turning point. So far, I just found the axis of symmetry. I know that this parabola is going to be cut in half by the line x equals 3. So 3 is the x value. So how do I find the y value? A turning point has an x and a y. I will substitute 3 into the equation. So 3, y equals 5 times 3 squared minus 30 times 3 plus 55. I go to my calculator, and I'm just going to put that in piece by piece. 5 times 3 squared is 9, minus 30 times 3 plus 55. 10. So my turning point is 3 10. So now it says, then place the function in vertex form to verify the turning point. So we're going to rewrite this equation in vertex form just to confirm that the turning point is actually 310. So I'll use a different color. Didn't change. I want blue. Oh, maybe it's this one. Okay, so first we separate and we say 5x squared. Oh, we have to factor out the 5 first, right? Because it won't work if we have a coefficient of 5. We need a coefficient of 1. So we'll say 5 times x squared. And then 5 times what will give me negative 30x? Negative 15. No, 5 into 30 is 6. Negative 6x. And then we have to find the new c. And we put the plus 55 out here. So how do we find the new c? B over 2 squared. B is negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. So our new c is positive 9. And that means we have to subtract 9. But don't forget the 5. So we're going to subtract 5. I'm running out of space. 5 times negative 9. We're going to add 5 times negative 9. All right. So that gives us, if we rewrite it as a binomial squared, x minus 3 squared. Minus because we have a minus 6, and the square root of 9 is 3. Plus, now we have to simplify this. So that's 55 minus 5 times negative 9 is negative 45. So minus 45, which is 10, right? So now it's in vertex form. Can you tell what the vertex is? Well, the vertex is going to be positive 3, because it's the opposite of what's in the parentheses, and 10. It is confirmed, because we got the same vertex when we did it using the formula. Okay. I'll leave that one for you to do on your own. I want to do number 9 with you. So let's go. Consider the quadratic function whose equation is y equals x squared plus 6x minus 40. Determine the y-intercept of this function. Oh, algebraically. Oh, okay. The y-intercept is always the constant. But why is that? Because the y-intercept is when x equals 0. So if you substitute x equals 0 into the function, the only term that's not being multiplied by x is the negative 40, the constant. So let's show it algebraically. Substitute x equals 0, because the y-intercept is 0, and that's what we're trying to find, the y that goes with the 0, right? So instead of x squared plus 6x minus 40, we're going to do 0 squared plus 6 times 0 minus 40, which just leaves you with a negative 40. So the y-intercept is 0, negative 40. Part B, write a function in its vertex form. State the coordinates of its turning point. So you can either use the formula for the axis of symmetry and then substitute that in to get the y that goes with it, or you can rewrite the equation in vertex form by completing the square. I would like to complete the square. So we separate the first two terms and find the new c. C equals b over 2 squared. The b is 6 over 2 squared. 6 over 2 is 3. 3 squared is 9. So there's a plus 9 that goes in here, and then the minus 9 out here. Sometimes students forget to subtract. Whatever it is you added in here, you have to subtract it to keep the equation balanced. Now we rewrite it as a binomial squared. X plus 3 squared. And then we simplify. What is negative 40 minus 9? Negative 49. So our vertex is negative 3, negative 49. Algebraically, find the zeros of the function using the zero product law. Okay. X squared. So let's write the equation again. Y equals x squared plus 6x minus 40. So in order to use the zero product law, we have to have multiplication. We're going to factor to find what did we multiply. We're going to rewrite this as a product of two binomials. So I know x goes here. Now I have to think, what two numbers, when I add them, I get 6. And when I multiply them, I get negative 40. Well, I'll start with the numbers that give me negative 40. Let's see, 8 times 5, that's not going to give me 6. 20 times 2, that's not going to give me 6. What about 4? 4 and 10. 4 times 10 gives me positive 40. Where should I put the negative so that I get a negative 6? Oh, negative 4 plus 10 is positive 6. There you go. So I'll put a negative 4 and a positive 10. So now to find the zeros, I need to see what values of x will make this equation equal 0. Well, if this factor, x minus 4, were equal to 0, the whole equation would equal 0. And if this factor, x plus 10, were equal to 0, the whole equation would also equal 0. Y would equal 0. So here, if x were 4, 4 minus 4 equals 0. So if I substituted 4 into this whole equation, I would get 0. And if x were -10, I would also get 0. So that is the solution. Those are my zeros. And graphically, it means that the parabola will cross the x-axis. These are the x-intercepts at -10 and 4. So these are called the zeros because at these x values, y equals 0. And if y equals 0, that means they are x-intercepts. Oh, sketch the graph. Look at that. Showing all relevant features in parts A through C. So I kind of started my sketch already. I just need to include my turning point. So, and my y-intercept. So my y-intercept is -40. That means this point here is -40, 0, -40. And the vertex is -3, -49. Let's use green, right? If this was my axis of symmetry to cut the parabola in half, this point is -3, -49. And we are done, ladies and gentlemen.